Hey everybody, and welcome back to Jim's Garage. This is going to be the first in a new series for total beginners that will lead on to advanced features, but we're going to be looking at how to install a firewall from scratch. I'm going to go through all of the installation options, so things like do you want to do it virtually or physically. I'll do both so you don't have to worry, and I'll talk about the pros and cons. I'll then talk about how to actually configure this once you've got it running, and we'll also talk through some of the rules, some of the advanced setups, VPNs, DHCP, all of those sorts of things. So how did I get here? Well, as you've seen from my channel, you'll know that I've done videos on things like Sophos XG. I've talked about how to install it, both physically and virtually. I've talked about having high availability, so having more than one firewall, and I've also spoken about how to configure some of the common setups. I've also done that for openSense. But this time we're going with pfSense, A, because it tends to be one of the most popular in the home lab community, and B, because I haven't done that before, and it makes a good topic for doing this for beginners. So for anybody who's coming into this new or trying to get into home labbing, having a firewall is probably one of the first things that you'll want to do. You're probably in the position now, if you're just starting out, where you've got an ISP router. Now, that's fine for your average setup where you just need to access the internet, connect some devices, and you don't have to worry about any advanced network features. But the whole point of home labbing is learning, and you may even want to do things like exposing services, so your media storage, your photos, having a VPN, all of those sorts of things. And for that, you shouldn't be using your ISP router. You want something that's a lot beefier, has a lot more security. That's where a firewall steps in. Now, don't get me wrong, a firewall is a router, but it's a router with a specific purpose of advanced security. So I've chosen pfSense for this video, and that ticks all of those boxes. Now, you might be thinking, what is pfSense, especially if you're new to this? Well, pfSense is a freely available firewall if you use the community edition, but they also have a subscription version with their Plus variant. Now, in this video, we're going to be using the community edition because it's free. But do bear in mind that if you want some of the advanced features or you want enhanced support, or maybe you're looking at this for an enterprise setup in your workplace, then there is that option available to you. And this option also applies to all of the other videos I've done, so things like Sophos XG and openSense. Also worth noting that there are other off-the-shelf products, so things like the Unify environment, whereby you can basically just buy the firewall, all that software's installed, and it's basically plug and play. So one of the first things we're going to want to do for a firewall is make the choice of whether we want it to be physical or virtual. You might also hear bare metal, that's the same as physical. But what does that mean, and what choice are you going to make? Well, when you start out, I recommend that you go for a bare metal physical setup. It's the easiest to understand if you're just starting out. It's basically just another computer, and it doesn't have some of the complex network setups, or at least more complex ways of thinking that are associated with a virtual machine, i.e. having virtual NICs and all of those sorts of things. Now, I started out with a physical machine, but I've now migrated to virtual firewalls, and on balance, I think in the end, that's probably the better option for a home lab environment. But like I said, I really want this to be for beginners, so I'm going to start out with a physical setup that hopefully you can match. Then when you're comfortable, you can take this to the next level and maybe virtualize it. So what are the pros and cons? Well, I've given you some of the pros for the physical variant. It's something physical you can hold. It's something simple to understand in your mind. You will see a wire going from your router, your ISP router, into your new firewall, and you'll see a wire coming out of it, which will go into all of your devices via something like a switch. Now, the cons to that is you're obviously going to need another device. That device is a single point of failure, but you've already got a single point of failure with your ISP router anyway, so it's not too much to deal with. The other benefits are it's simple to upgrade. You can just turn this off and plug things in, boot it back up, and it should be okay. Downsides are there might be some extra power draw, especially if you've already got a server or something that you want to use. You could reap the benefits of consolidation if you were to virtualize it. So let's have a look now at the benefits of virtual, and it's pretty much what I just said. You can consolidate your infrastructure, so you don't need to have a separate box, you have fewer devices on, less power consumption, and it also comes with things like high availability, failover, especially if you're using some shared storage. I won't go down that route, but if you're interested in that, check out things like my Ceph video, where we have virtual machines split between physical hosts, that when it fails, it should replicate onto another node, thus it keeps your firewall up. Anyway, I want to keep this to beginners, so enough of that stuff. So what do I recommend for hardware? Well, thankfully, pretty much anything is going to work, as long as it supports AES. Now that's the Advanced Encryption Standard, and that's a hardware piece that's built into the CPU. So effectively what happens is a process of hardware offloading. So when it's doing all of its fancy encryption and decryption on the fly, it hands that over to a specific part of the CPU that's dedicated for doing that. It's basically an ASIC, an application-specific piece of hardware. Without that module, everything has to be emulated, and I think in pfSense it actually requires that you have AES support. Now, luckily, I think that's been available from anything from sort of an Intel 6th generation, so that's sort of 7, nearly 8 years old now. So basically, anything that supports AES, you need to go and get. And that's also true for AMD, but I think they've also supported it for a similar amount of time. Now, in terms of the actual CPU itself, you don't need anything beefy. Now, what you do need to understand is that as you add more advanced things to your firewall, so there are specific things around traffic rules, intrusion protection and intrusion detection. Those things, and we're not going to go into too much detail in this beginning video, those do require more CPU resources. So the more rules and advanced things you do, you will require a beefier CPU and some more RAM. But for starting out, you're absolutely fine with a basic sort of dual core, hyper-threaded, 4-core CPU, that kind of setup. And you probably want a minimum of about 8 gigabytes of RAM. Now, you can probably get away with 4, but I recommend 8, and there's probably not much difference in cost. In terms of hard drive storage space, I recommend getting at least sort of 120 gigs. A solid state drive would be nice, but you could probably get away with a hard drive. A firewall doesn't tend to be too read and write intensive. A lot of this stuff will run from the RAM anyway. Similarly, the PSU doesn't have to be expensive, and you could pretty much pick up any capable machine that will fit this specification for probably 50 to 100 pounds. Similar price, probably less in dollars. Just the US market's a lot cheaper. Anything basically that's relatively recent, low powered and second hand. One thing that is vital is that you have more than one NIC. That's a network interface card. That's because, as I mentioned earlier, you'll need one for the WAN, the wide area network, aka the internet, that will come from your ISP router, and you need one for your LAN, your local area network. This is similar to the thing that's on your existing ISP router where you plug all of the plugs in the back, those Ethernet ports. Now that you've got something simple like that set up, and there's a whole section of the technology space that's now spun up for those, especially a lot of the low-powered Intel devices coming out of China, the N100 CPUs that have many ports on the back, that'd be a good start out for a firewall. But again, if you've got an old PC that's lying around, put it to use. Buy a cheap network card, stick it in, and go for it. If you're feeling a bit more adventurous, you could use this same setup. You could add some 10 gigabyte ports, or if you're not quite up to that yet, you could do some 2.5 gigabyte ports. Bear in mind that if you are going to do that, anything sort of above a 1 gig, you're going to need to make sure that your switch supports that. So now that you've got your hardware, we're ready to start the installation process. But before we can do that, we've obviously got to go and download it. Now, if you are to Google pfSense download, you're likely to come to this page, their official site /download. And this will ask you to create an account. So if you click download, it's going to take you to here. You're going to want to add that to the cart, and then it's going to ask you to create an account. Now, that's a bit annoying. I can understand why they kind of do that, but the old method still works. If you go to here, and I'll put this in the description below, you can actually find all of the ISO images for this download. Now, an ISO image is basically a disk image, so like a DVD, that you will burn to a USB stick, and then you'll stick into your computer during boot. The exact same process as if you've installed any operating system before, like Windows. Don't worry, we're going to burn this to a disk and then we're going to install it to a physical machine. Now the one you're looking for, if you want to burn to a disk, you're going to use this one here. But if you're using a memory stick, it's this one here, conveniently named memstick. So I chose this one here, 2.7.2. So you want to click on that and download it. And then we're going to use that later in a minute in Rufus to burn that to a USB stick. You'll see that it's now coming down. We need to then extract that image. You can get that from rufus.ie, and as the title says, create bootable USB drives the easy way. So you'll want to go down on this page to find the download. You want the 4.5 version. You can either get the executable or you can get the portable version that doesn't require an install. That's the one I typically use. Once you've got that downloaded, you want to open it up. So now you've got Rufus open, you want to get your USB stick and you want to stick that into your computer. When you stick that into your machine, it should automatically populate with the one you want to use. Then you need to click select and you want to select the image that you just downloaded. Once you've selected that, you want to hit start. Click OK because it's basically going to delete everything on this USB device, so do make sure that you've backed it up. Now it's deleting the USB and it's going to copy that over onto the disk and make that bootable. Now that that's completed, you need to remove the USB drive from your PC and you're going to want to plug it into the machine you're going to use as your firewall. Now for this video, I have an MSA1 lying around. Now this thing is absolutely overkill for a firewall, but you will notice that it's got the two ports here that I was talking about. So I'm going to use one for the WAN and one for the LAN. Now we want to take our USB stick, we're going to plug it into this machine, and then we're going to go into the BIOS, and we're going to make sure that it boots from the USB device. You might not need to go into the BIOS to do that. Sometimes there's a handy key like F10 or F12 for the boot menu. So I can't give you explicit instructions for every piece of hardware, but look in your manufacturer's manual and make sure that you select the right boot option for you. Now, full disclosure for this video, as you can see, I'm going to be installing this on a virtual machine, but that's only because I don't have a good way to be able to do screen capture of a physical installation. Before you switch off, the actual installation steps for the virtual machine, what you're going to see here is exactly the same as you'll see on a physical install, and I will be switching to the physical install when I actually get the web interface up and running. So this will be exactly the same, and this will also be useful for future videos, but I will come back to do a specific video for how to virtualize pfSense. So now you should be in a position whereby your USB stick is plugged into your pfSense, you've got the power in, and you've selected the BIOS option to boot from the USB stick. You might want to have the WAN plugged in, and you might want to have the LAN plugged in, but those aren't essential at the moment. The key thing is that it has those two NICs, and those will be detected during the installation stage. You can plug those in once everything's installed, and because of things like DHCP, etc., it will pick up those IP addresses automatically. So when you're ready, let's begin the process for installation. So here you'll see that it automatically tries to boot the first time. So you can now see that it's now running this from the USB stick and is putting that into memory. Once that's loaded up, you'll be able to then do the actual installation. So install it to the drive itself. So here we see that we've got the installer. We want to accept the end user license agreement. Now we get some options. So we can launch a shell for rescuing if it's a broken installation, or we can recover the configuration from a previous installation if we're installing a new pfSense and we've got a backup from a different version. i.e. you might have a physical machine, for whatever reason it's been corrupted, it's broken, hardware failure. As long as you've got the backups, and we'll come on to that later in the series, you can restore a configuration file to a fresh installation. Obviously, for this video, we're going to do an install pfSense because this will be the first time that you've installed it. Now, how do we want to partition our disks? A few things here, and some of these get a little bit tricky. So the default is guided root, on ZFS. ZFS is a software RAID storage configuration. So this is designed for multiple disks. So RAID gives you redundancy. It's not a backup. And that means that if you had a firewall, typically this is a critical piece of your infrastructure, you wouldn't want a single disk failure to bring down your entire network. You'd likely have 2, 3, or possibly even more drives that all have the same data on them, such if one drive fails, other copies of that data exist as is on those other drives. Or you could also go for the UFS, which is a different file system technology, and it's not the default recommendation. And from all of the reading I've done and just past experiences, I've always trusted ZFS. It tends to be a better technology. So I'm going to go for the ZFS. Do note that obviously for experts, and even I don't consider myself when it comes to RAID setups, there is the option to go and manually do this yourself. So I'm going to go for the guided route on ZFS setup. Now you get a few options here. I'm actually going to keep these as default, but let's have a quick look through so you understand what's going on here. So this is going to be a stripe. So what this would do is put the data across all disks. Now I've only got one drive in here, so that's absolutely fine. And when we come onto it in later videos, one of the benefits of having the virtual machine is I don't really care, because I'm going to have this spread across multiple physical nodes so that one device failure shouldn't really matter. Plus, backups are going to be heavily focused on this as well. But if you had more disks here, you'd be able to click on that and you'd be able to set up things like a mirror, a RAID 1.0 known as a 10, a Z1, Z2 or Z3. Now, as you choose these higher versions here, you will need single, redundant, double, triple. You kind of understand how many drives you're going to need. I do recommend you go and read up the documentation on any of these if you want more information. I have covered them on previous videos around things like TrueNAS, for example, which has a lot of documentation around the different RAIDs levels. So because I've only got the one drive, I'm going to go for the stripe with no redundancy. You can obviously rescan the devices if you've added things in. You can change the pool name. Then you get onto things like 4K sectors. So I'm going to say yes, that's the default. I don't want to encrypt these disks, but if you wanted to, you could encrypt them. Likely a good idea if you're in a sensitive environment or an enterprise environment. It means that someone can't just pull the disks out and then get the firewall configuration that you've got in there. The partition's going to be GPT. It's going to have a gig of swap. So basically this is RAM on the disk that it can use. We're not going to swap the mirrors and we're not going to encrypt the swap. But if you want to do that, go and do it. I want to change this stripe from 0 disks. I'm just going to change it to a stripe. So I'm going to click enter. Now it's going to say which disk. So this screen here obviously shows my QEMU. This is a virtual disk, but whatever it says there, if you've got 1, 2, whatever it may be, choose the disk that you want to do. So you need to press up and then you need to press spacebar. That'll put an asterisk in there to select it. Then you want to hit return. Now you'll see that it says stripe and 1 disk selected. So now that we're ready, we can scroll to the top to the install, make sure that's highlighted and click return. Now it's going to say this is the last chance, all that data is going to be destroyed. So I press the left arrow to hit yes and I hit return. Now you can see that much like any installation, it's now extracting the files from the USB stick. It's going to be copying that from the RAM and then onto the disk, the virtual or physical disk you've got, and then it's going to want to reboot to finish that installation. So I'm going to hit reboot. That should now reboot my machine and finalize the installation to the drive. Now that it's rebooted, you can see that it's booting now from the drive, not the USB itself, and it's completing all of the installation steps. Hopefully by the end of this, we're going to see, there we go, we're getting these link states changed to up. Now, this is VTNet. These are virtual adapters. Now, on yours, it should give you the actual names of yours. So if they're Intel, for example, it should say Intel. And once this is completed, we're going to do some simple setups via the command line interface, and that will make sure that we can then access this through our web browser, because all of the configuration from then should be through the web browser, and you'll only need to come back into the command line interface if something's gone wrong. So because I'm doing this on a virtual machine, the readout's a little bit screwed up, but on your readout on a screen, it should say, should VLANs be set up now, yes or no? Now, depending on how you've got your network configured, if you're a more advanced user, you should already know about VLANs and what they are. Typically, for your first time setup, and if you're just plugging this into your ISP router and you're looking to replace that, you should say no. A virtual network, a VLAN, is something we'll set up later, because one of the benefits of having the firewall is you can set up virtual networks. So basically think about splitting up your switch and your network into lots of sub-networks, which is a great thing for segmenting your network and having different devices, i.e. ones you trust, away from ones that you don't trust. Or just being able to put in some access control so that only certain files are accessible by certain machines. So we're going to press no. So I press N. Now it's going to ask enter the WAN interface name, or A for auto detection. Now for this one, you're going to have to choose which one is your WAN. Now if you don't have anything plugged in, it doesn't really matter too much. The key thing you can find out here is this address here. This is called a MAC address, a machine allocation address. Now, those are all unique to your machine. They're not globally unique, but they're unique enough so that you should be able to identify it. Now, if you've only just got two NICs, two ports, it doesn't really matter which one you choose because you'll be able to just flip them over. Now, obviously, it makes sense if you can to try and find these out so that you can set the right one to the right one. If you do get this mixed up, just swap the cables over. It really doesn't matter. In my virtual machine setup, I know and I have complete control over these MAC addresses because these are virtual, so I can manually choose which one I want. So in my instance, it's VTNet1. It's this one here, which is going to be my WAN. So I'll put in here VTNet1. Key thing for you is just to choose either one of them if you're not sure, or if possible, try and choose the one which has the Ethernet going from this machine into your ISP router. Don't worry if you do get it wrong. Like I said, you can swap this over. So I'm going to hit return. So now I've set the WAN interface name. It's going to ask me for the LAN. And that's because I've only got two set up on this. I've only got two NICs. If you had more than two NICs, like I mentioned before, you might want to go and add additional cards, add some specific 10 gigs or 2.5 gigs, whatever it might be. You could obviously then choose from all of those which ones you want. In this instance, I've only got the other one to be used. So I'm going to do VTNet0. And this is the one where you will plug all of your other devices into, either directly one PC into it, or you'd plug a switch into it and then plug all of your devices into that switch. So now I'm going to hit return. So now it's asking for confirmation. And I'm going to say yes because this looks right. So now that that's done, it's going to try and get some IP addresses from that and then hopefully set them up and you should be done. If it can't do that because you haven't plugged in, it'll time out and then hopefully you should be able to then plug it in. Maybe you need to reboot it. You shouldn't. It should be dynamic and pick it up. But then you should progress onto the main menu where you'll see your IP addresses that you've been assigned. So now you can see that it was finalizing the installation and it's dumped me out right here. So you'll notice that these IP addresses aren't public IP addresses. Now, there's a reason for that. That's because specifically I'm double natted. So I've got a firewall in front of this firewall. So this is giving me an internal IP address. If you plug this into your ISP router, you're likely also going to get an internal IP address. That's because you're double natted. That stands for Network Address Translation. And it's basically a way of making sure that the finite number of IPv4 addresses can be split into more. So think of it a bit like you might have the same phone number as somebody, but actually you've got an area code in front of that. So it means that more than one person can share that address. Not quite the same, but what this does is, say you've got one IP address, let's say it's Cloudflare, they're 1.1.1.1. Now, behind that, they're going to have hundreds, thousands, probably millions of machines. And network address translation takes that one fixed 1.1.1.1 and it allows it to translate traffic internally, such that it knows when traffic comes in, it knows which machine to talk to inside. So it says, hey, that bit of traffic needs to go to this machine, that bit of traffic needs to go to that machine, and vice versa. And it does that through an ARP table, which is an address resolution protocol, and that's where it stores basically who said what using this IP. It basically slices it up and gives it kind of a lease or a share of the IP address for a period of time. Now, if you are in this position, double natting isn't ideal, but a lot of ISP routers these days don't allow you to put the modem into bridge mode, or even better, modem mode. Now, if it goes into modem mode, this here will show your actual IP. And that makes things like port forwarding, that means exposing your internal services to the internet, much easier. That's because you can directly manipulate firewall rules on one firewall. If you're double natted, you're going to have to do a port forward on your original ISP router, and then you're going to have to mirror that again on your pfSense installation. Worst case scenario, you might be behind what's called CGNAT. That's carrier grade network address translation. If that's the case, then unfortunately you don't even get the luxury of having an IP address to play with, and you won't be able to port forward. If that is the case, then I do have some videos on how you can circumvent that using things like a mesh network, but I don't want to get too far down that route because I want to try and keep this as simple as possible. Next up, you'll see that I've got a LAN IP address. Now, that's just the default that pfSense uses, and it's the 1.1/24 network range. That means that you've got 1.1 all the way to 1.254. Now, at this point, we should be able to go to this address here and access the UI. Now, you can only do that obviously if the machine that you are on is plugged directly into that LAN port. So first priority, make sure you're plugged into the right port on the back. And then secondly, make sure that you type this into your browser. And so if I head over now to 192.168.1.1 in my browser, that's the default gateway, that's the IP address of the firewall by default. We're granted with this screen. Now you might be thinking, uh-oh, this is not private, but that's fine and we could fix that if we wanted to. That's just because this is using a self-signed certificate. If we click on advanced and we proceed, we should get to the pfSense login page. So let's log in. So we're going to use admin and pfSense, which is the default. And now we're into the setup configuration wizard. So let's have a quick walk through this, and then we'll end the video once we've done the initial installation. So let's click next. Here it's going to tell you about the support we can do, which I believe is the pfSense Plus. We're going to ignore that, go next. So now we can give this thing a host name. pfSense makes sense to me, so I'm going to leave that as is. Now you can also have a domain setup. We're getting a bit advanced already, but these are terminologies that you should familiarize yourself with. This might be quite useful if you've got, say, your own domain name. So for example, jimsgarage.co.uk. I could have home.jimsgarage.co.uk. You get the idea. The benefit of that is you're going to assign things to a domain. That leads to things like integrations with Active Directory and other LDAP services. And it also means you can tie it in nicely with your DNS resolver and all those sorts of things, so you can have everything hosted on the same domain. Doesn't make too much of a difference, so don't worry about it now, and you can change this in the future if you wanted to. Next, we're going to get onto the primary DNS server. Now, by default, this is blank, and if you've just been using an ISP router, it's probably set to the ISP routers or the ISP's DNS resolvers. That's not great for privacy because they're in the business of selling all the data that you're looking at. So you could do something like 1.1.1.1, which is Cloudflare, and maybe you want a backup of 8.8.8.8, which is something like Google. Entirely up to you. In future, and if you check out some of my other videos, I use Pi-hole for my ad blocking and my own DNS resolution, and that uses an encrypted tunnel up to Cloudflare to protect some of my DNS. We're not going to go too far down that route because DNS gets quite murky and the privacy around DNS is It's not great at the best of times, but if you put in the values I'm showing you here, this will get you up and running with some sensible defaults, and it should be notably quicker to access websites compared to your ISP domain resolver. Now, once we've set this, we actually want to untick this. If we don't untick that, it's going to pick up the DHCP and the DNS servers from your internet service provider and negate what we've just done here. So let's click next. Then we're going to do a time server. So I'm going to leave this as is, but basically in layman's terms, the NTP is a network time protocol. So what it's basically doing is synchronizing the time of your firewall to a established time on the internet. The benefit of that is all of your logs, well, the firewall will have the right time, and then all of the logs will also have the right time, which is imperative for understanding network flows, the order and sequence in which things happen. It's also really important with a security lens on. If you're trying to do any sort of threat analysis and find out what's been going on in your network, you want to have that in sequential order so that you know that what step led to which consequence. I'm going to leave this as is and click next. And then it's going to come on to your WAN interface. So for your WAN interface, remember, this is your internet. You have 4 options. Now, I'm going to leave it as DHCP. That's because my network provider provides me a non-static IP, a dynamic IP. But common other options are PPOE, where you'll typically have a username and password and possibly a VLAN, and you'll need to implement that. So if you select PPOE, you'll get some options to put in your username and password. I'm going to leave that as DHCP because that's my setup, but if you do need those values, you may have to log into your existing ISP router, or you may actually have to ring up your ISP and get those credentials. One thing that's also important is you might actually need to put in the MAC address. So for this demonstration, it's not going to be required, but if you're doing something more fancy like trying to actually bypass your ISP router, you may need to spoof its MAC address, so the MAC address that's on the router itself, because sometimes that is the identifier of your account. They just use the ISP's MAC address, the router that you get, that box, that's your identifier. So if you put that in here, this firewall that you've created can spoof itself as the one they sent you. So I'm going to skip through the static IP configuration, and I'm going to leave everything because it's DHCP. Here you see you'd put in your PPOE configuration once you've got your username and password, etc. And we're going to scroll down. We're going to block private networks from entering via the WAN. What this is doing is basically blocking private networks, so local networks, from accessing and entering via the WAN. That's typically how you'd want this from a security standpoint. And we're going to block bog-on networks, so these are non-internet routed networks. And click next. And then it's going to ask us, well, what do we want the default network to be? Now, if you look in the top, we're actually connected to 192.168.1.1, and that is the default that it comes with. Now, that's probably going to be fine for most people. This might actually cause a network clash with your existing ISP network. So you just need to change this to whatever you want. So for example, you could have 2.1, and then everything on this network would be 2.1, 2.2, 2.3, etc. And you can also change the size of the network. Now, as I'm trying to do this for beginners, I'm going to leave this as default, and we'll come on to things like subnets and VLANs and all those sorts of things later on in the video. Just know that if you do use the default, you might have a clash, and if you do, you're going to have to change this value here, probably to a 2 or something like that. Do note that if you do change this address whilst you're logged in here, it's going to boot you out, so it won't be 1.1 anymore up here, it would be 2.1. Now it's going to ask us to change the password because we're using the default, so put in a password and we can go from there. Now you've completed the wizard and you're ready to hit reload. So this should go through now and apply all of those variables that you've put into that and reboot the firewall with those. So now we're ready. So let's quickly check for updates. Really important that we check for updates on our firewall. I think this should be fine because it's 2.72, which I think is the latest version of pfSense. But let's see what it comes back with. No, we're up to date, so that's great. So we can now hit the pfSense in the top corner, and that will take us back to the home page. And here we basically see the home page for pfSense. And it's going to give you some system information and lots of other stuff. Here you go, you can see my network adapters for WAN and LAN, as well as things like the CPU, the memory, swap usage, etc. Now I'm going to park the video here because, as you can see at the moment, if I go to something like BBC, you can see that I'm accessing that now through this firewall. So everything is working as expected and we have internet access. If we're to do something like a speed test, you've got to bear in mind that I've got this through a 1 gig link, but you can see that I'm fully saturated in that 1 gig link, and this is actually still through a virtual firewall. So thanks for watching, everybody. Hopefully now that explains how to install pfSense from scratch. Now I appreciate there might be some difficult terminology there. I've tried to dumb that down as much as possible and be friendly and open, but if you do have some comments, please drop them below. Any questions, queries, be happy to answer them. Hop into the Discord if you need a little bit more hands-on assistance. There's loads of really nice folk in there. Anyway, in the next video, I'm going to go through some of the actual configurations, so some of those things that I've already mentioned. Bit like my openSense video, we'll go through most of those topics. Anyway, if you like this video, please give it a thumbs up, hit that subscribe, and I'll see you on the next one. Take care, everybody.